Greetings everyone, I am Rahul Mishra. Today the topic is anti-forensics. So, from the name itself we can get an idea about what it is. Anti-forensics is a technique applied to increase the difficulty of using forensics on the device to find traces of evidence. Usually forensic experts try different tools and methods to find evidences from a device. Anti-forensics is used to prevent the expert from doing so. This can be done by a lot of ways, like we can encrypt data or wipe the data completely, and we can change timestamps. A timestamp is the current time of an event that is recorded by a computer. Through mechanisms such as the network time protocol, also known as NTP, a computer maintains accurate current time calibrated to minute fractions of a second. Anti-forensics is more than technology. It is an approach to criminal hacking that can be summed up like this: make it hard for them to find you and impossible for them to prove they found you. Now, there are various approaches. Let us start with them. The different approaches or techniques used for anti-forensics are: first, secure data deletion; second, overwriting metadata; third, encryption; fourth, steganography. We will discuss all these techniques one by one. We will start with secure data deletion. Before talking about data wiping, we should understand how data deletion works. For that, we should understand how an operating system locates a file on the disk. So, when an operating system is asked to store a file, it stores the file to an empty location and also maintains a record in a table where data is stored along with other information. Now, when user deletes the file, the operating system only deletes the record from the table. The actual data which is stored in memory is not deleted. The operating system only forgets the location of the data and treats that location as free memory. So, if the operating system wants to store new data, it can overwrite that part of memory. Secure data deletion or wiping of data removes the entry as well as overwrites the memory with either zeros or random values. The original data cannot be recovered from memory after wiping. These processes are slow. In Linux, there is an option for slow formatting which replaces the memories with 0. Practically, it can be done by formatting the whole drive and then filling it up with random unnecessary files in order to overwrite existing data. Overwriting metadata. Now, metadata is the data or information that provides information about other data. It contains every information about a file, an application, even the operating system itself. Information like name, date of creation, access date and time of last update, etc. are found on metadata. Certain tools like timestamp can be used to overwrite this metadata so that the forensics expert will not be able to trace back the date and time when the device was in use. Windows registry stores every information about how and when the system has been used. Forensics experts surely use registry contents to recreate the crime scene in order to trace back how the attacker has used the system. Changing the contents of registry intentionally helps the attackers to clear the tracks. Next is encryption. One of the greatest techniques to secure data and also biggest nightmares for forensics experts. A part of cryptography which converts plain text to ciphertext or text that is not in human readable format. Cryptography works by using an algorithm to encrypt or decrypt data which is usually public. Two inputs are provided to this algorithm. One is the data itself and the other is the key. Now, key is the most crucial part in encrypting data. The key remains private to the user. It is nothing but some large random values. The larger the key, the more secured is the data. Attackers use this technique to encrypt all their drives, which can only be decrypted by key that the attacker knows. Cryptography can also be used at the application level. For example, Microsoft Word can be configured to encrypt the contents of a document by specifying that the document has a password to open. All the older versions of Microsoft Word encrypted documents with a 40-bit key that can be cracked with commercial tools. Modern versions can optionally use a 128-bit encryption that is uncrackable if a secure passphrase is used. Network traffic can likewise be encrypted to protect its content from forensic analysis. Cryptographic encapsulation protocols such as SSL and SSH only protect the content of the traffic. Coming to the last part, which is steganography. Steganography is an act of hiding data or a file inside another file. For example, hiding data or file inside a text, audio, video, image and so on. Hiding data inside another file does not have big changes in the file in which it was hidden. The advantages of steganography over cryptography alone is that the intended secret message does not attract attention to itself. In modern digital steganography, data is first encrypted by the usual means and then inserted using a special algorithm into redundant that is provided but unneeded. Data is part of particular file format such as JPEG image. Now, how do attackers achieve their goal of anti-forensics? Certain tools are used for this purpose. Secure data deletion can be achieved by deleting the files from the driver or formatting the whole drive and then filling the drive completely with random data. Case study on encryption: hundreds arrested after police crack encrypted chat network. European police infiltrate EncroChat, go on to track down on crime kingpins and seize guns, drugs, cars and millions in cash. Law enforcement agencies in Europe recently cracked an instant messaging system used by organized crime before the ensuing police operation ultimately led to the arrest of more than 800 suspect criminals, mostly in the United Kingdom. The service, dubbed EncroChat, was used by 60,000 people worldwide to manage their criminal enterprise. EncroChat's operating system operated on specially customized Android phones that could switch between both systems. The encrypted communication platform included features such as VoIP or Voice over Internet Protocol calls and self-destructing messages that would delete themselves from the user's device after a certain time period elapsed, as well as a panic wipe feature which would wipe the device clean of any data after a 4-digit code was entered. The service sold these devices for £900, a pop with an additional £1,350 charged for a 6-month subscription. According to Motherboard, the breakthrough was achieved by French authorities, which were able to penetrate the EncroChat network and install a technical tool that allowed European law agencies to read over 100 million encrypted messages that were being sent through the service in real time. Once the service realized that the jig was up and it had been compromised, it alerted its users on June 13th, telling them to ditch their devices. But apparently this warning came too late, as the law enforcement swooped to arrest hundreds of criminals in UK, France, the Netherlands, Norway and Sweden. Case study on steganography. Busted alleged Russian spies used steganography to conceal communications. Deep cover Russian intelligence agents hid electronic messages behind computer images. In a case that smacks of Cold War spy novel, the FBI arrested 11 suspected Russian spies who for years had blended into day-to-day American life in the suburbs and cities. Apart from hiding their true identities and posing as legitimate American citizens, the suspect also masked their communications with their intelligence agency back home in Moscow using an oft-forgotten form of stealth communication, steganography. According to US Department of Justice legal filings, the defendants use a steganography tool, one that is not available commercially, to conceal their electronic communication with Russian officials in the so-called SVR, a Russian Federation foreign intelligence body. We will discuss about a few tools here. There are certain tools used for encryption in steganography. They are: first is Veracrypt, second is Cleopatra, and third is S-tools. We will try them one by one, but first let us understand what is on the fly encryption. Live encryption, on the fly encryption, transparent encryption, real time encryption are all different names for the same concept used by SafeBit to give simplicity and efficiency to the encryption process. When you open a file from the container, it will automatically be decrypted. Once the file is closed, the container is automatically encrypted again. We will have a demo of Veracrypt here. Let us see how we can create an encrypted container. Before that, let us understand what an encrypted container is and the importance of it. So, an encrypted container is basically a logical drive which can be mounted on any system if you type the correct password. It looks like a file which is encrypted when it is unmounted. So, any unauthorized user will not have access to this encrypted container. Coming to its importance. While investigating a case, there can be situations where your digital evidence might fall into wrong hands. In that case, you as an investigator need to make sure that no one will be able to access the evidence or tamper it. So, we gather all the digital evidence and store it in an encrypted container before submitting it to the right authority. So, now we move on to the demo part. We double click to open the software. First thing, we need to create an encrypted container. In order to do that, we click on create volume. Then we choose create an encrypted file container from the list. There are other features of Veracrypt as well. For example, it can encrypt an external drive like a pen drive. It can also encrypt a system drive, for example C drive, which stores the operating system details. But here we are just looking for an encrypted container. So, we click on next, then we choose standard Veracrypt volume from the list and click on next. Now, we need to create the file. We click on select file, we then choose a location to store it and then give it a name. Finally, we click on save. For our demo, we stored it on desktop and saved it with the name sample. Then we click on next. Next, we need to select the encryption algorithm and the hashing algorithm. By default, it chooses AES as encryption algorithm, which is one of the most widely used encryption algorithms today. SHA 512 is a very secure hashing algorithm, so we do not make any changes. We click on next. Now, we need to declare the size of the container. The size can be in kilobytes, megabytes, gigabytes or even terabytes. For our demo, we choose megabytes or MB and keep the size 10. So, it creates a file size of 10 MB. Then we click on next. Here we need to give a password. Remember, this password will be used to access the container. Anyone with the password will be able to access it. So, always keep a strong password. A strong password can be of 13 characters with a combination of uppercase letters, lowercase letters, numbers and special characters or symbols. Veracrypt itself suggests us to keep a minimum of 20 characters password. But for our demo, we are just keeping a small password. Since we kept a small password, we will get a warning message. We just click on yes to continue with the short password. Now, it is going to generate a random data using our password. In order to generate that data, it is also going to track your mouse movements. So, it is asking us to move the mouse as randomly as possible inside the window. The longer you move it, the better. Once the color changes to green, we click on finish to create the file. As you can see, the file is created on the desktop. Our first step is over. Now is the time to mount it and store some files in it. We click on next. Then we click on cancel to go to home screen of Veracrypt software. At the home screen, we will click on select file, then traverse to the location where we stored the file. In our case, the encrypted file is stored on the desktop with the name sample. So, we go to desktop and select as file sample and click on open. Then we choose a drive letter from the list of available letters. For our demo, we chose the letter E. Then we click on mount. It will ask for password. You need to type the same password which you used while creating the file. Click on OK. It will take a while and also the software might not respond during this time. So, we wait. Once it mounts on the drive letter, we double click on it to open it. We can also go to this PC or my computer page. There we will see the drive mounted. For example, in our case we mounted it on E. So, we can see E drive of 10 MB. Now, we can store any file inside it which is lesser than 10 MB. For our demo, we will create a text file named sample text document and store it inside this container. We just add a line inside the text file and save it. Now, it is time to dismount it. So, we select the drive where it is mounted and click on dismount. This will make sure that the container has disappeared from the drive. Now, your sample text document file is stored inside this sample container. If anyone tries to open that container, he will only see encrypted data. Anyone with the correct password will be able to see the contents of the container. Now, we will have a demo of Cleopatra. Let us look into how we can send encrypted message or a file over an unsecure network. In today's world, we use technology a lot. We store and share our data with others. However, there is a concept of privacy. We do not want a third person or an unknown user to know about us or to get our information. That is why we always look for different methods to share our data in a secure manner. One of the most widely used technique is to encrypt our data before sending it, and then the receiver will decrypt it. In this way, only we and the recipients will be able to see the actual message. Once the data is encrypted, we can share it by whatever means we want to. So, today we will see how to do that. We are going to use an open source software called Cleopatra. This application uses asymmetric key encryption. We double click on it to open it. In order to encrypt or decrypt any data, we need a big random set of characters called a key. For encryption, we use a public key. For decryption, we use a private key. We share our public key to those people who want to send us a message. We keep our private key a secret. Whoever wants to send us a message needs to encrypt the data with our public key. It is completely safe to share the public key. The hackers cannot do anything with it. The sender needs to use our public key to encrypt the data and needs to use his private key to sign the data. In this way, only we will be able to decrypt it. Also, with the signature of the sender, we will be able to verify the authenticity of the message. So, in Cleopatra, we need to generate keys. For our demo, we will generate two pairs of keys, one for the sender and the other for the receiver. The sender will send the signed and encrypted message to the receiver. The receiver will then decrypt the message and verify it. So, we click on new key pair, then we type a name and email address of the recipient. Here for demo, we used sender as name and sender@email.com as email. Create to finally confirm the creation of the keys. Now, you need to type a password in order to secure your private key. You can only access the private key if you type the correct password. The public key can be accessed without any authentication. You must remember to use a strong password which is a combination of letters, numbers and special characters or symbols. For our demo, we have used a small password. Thus, it shows a warning message. We click on take this one anyway to continue. Then it will generate a key pair. Now, you need to upload the key pair to directory service. It is a database of all public keys that are generated in Cleopatra. So, if anyone wants to send you a message via Cleopatra, they need to download your public key from this directory service. You can also keep a backup of your keys in your system by clicking on make a backup of key pair. For our demo, we just upload it to directory service. We click on continue to provide the permission to upload. Once uploaded, we click on OK. Then we click on finish. So, the sender's key pair is generated. In order to send a message, the sender needs the receiver's public key. So, for our demo, we generate another key pair which will belong to the receiver. We will do it the same way as we did before. Now, the two key pairs are generated. We now need to sign and encrypt a message. In order to do that, we click on Notepad option in the top bar. We type the message in the notepad that we want to encrypt. Then we go to the recipient section. We choose sign as sender. Since sender needs to sign the message in order to verify the authenticity, then we choose receiver from encrypt for me option. In this way, the receiver's public key will be used for the encryption process. Then we click on sign or encrypt notepad. At this point, since the sender is signing the message with his private key, he needs to type the password to access the private key. Then click on OK. The encrypted message will be generated. This message can now be shared to the receiver by any medium. The receiver now needs to decrypt the text and verify the signature of the sender. In order to do that, the receiver will open Cleopatra at his system. Then he will go to the notepad and paste the text shared by the sender. Then he needs to click on decrypt or verify notepad. At this point, in order to decrypt the message, the receiver is going to use his private key. So, he needs to type the correct password in order to access the key. This is the same password that he used to generate the key pair. If he types the correct password, he will get the decrypted message. Also, if the sender is actually sending the message, then the green box signals the authenticity of the sender. If signature was not verified, then the box would be red in color. Now, let us see how we can sign and encrypt a file. In order to do that, we click on sign or encrypt file from the menu. Then we need to traverse to the location and select the file we want to sign and encrypt. For our demo, we create a file on text with the name sample and add some content to it. Then we select that file and click on open. Again, we need to choose sign as sender and choose receiver under the encrypt for me option. Then we click on sign or encrypt. If it asks us to type the password, we will type the password. After the process is done, we click on finish, demo as tools. Now, we will see how we can hide a file inside an image. The process is called steganography. Attackers use this technique to hide their messages inside other files so that no one can use it. For our demo, we are going to use a software called S-Tools. This software allows us to hide a file inside a bitmap image. In order to use S-Tools, we open the software and drag and drop a bitmap image inside it. For our demo, we have a bitmap image named as original zebras. So, we drag and drop this image in the software. Now, we need to drag and drop the file that we want to hide inside this image. For our demo, we are going to hide a text file named as sample file. We drag and drop this file over the image in STools. Now, it will ask us for a password. Later on, if you want to unhide the file, then you will need the same password to unhide it. We type in a password and click on OK. This will generate a new file inside STools with the name hidden data. We need to save this new file. Here we save it as new file .bmp. Remember to use .bmp at the end as extension, since the new file generated is a bitmap image. Then we click on save. Since we did not specify any location, it will save the new file in the same location where STools software is stored by default. So, in this way we hide a file inside a bitmap image. We can now share this file to anyone. If the receiver wants to unhide the file, then he needs to open STools and drag and drop the image in which the file is hidden. For example, in our case the hidden file is stored in new file .pmp. So, we drag and drop that image to the software, then we right click on the image and click on reveal. It will ask for the password. This is the same password that was used while hiding. We type the correct password and it will reveal the file hidden inside it. If you want to save the revealed file, right click and click on save as. Then choose a location to save, give it a name, mention the extension of the file, in our case it is txt. Finally, click on save. Here we saved it on desktop. Now that the file is saved, you can open the file to see its contents. I would like to conclude here that with each passing day, counter forensics tools are becoming stronger. The fact that encourages their use is that these tools are openly available and easier to use. They are further benefited by standard methods used by forensic tools, and they are being well documented, which makes it more convenient to either get away from them or causing disturbance in their own working. No software is perfect and bugs are discovered every now and then as points of vulnerability by criminals. Hence, it is required that investigators are updated and aware of new bugs in the CFTs used by them. Updating forensic tools after putting ourselves in hackers' shoe can help in building a tool which is much less prone to attacks. This, however, requires a deep and thorough understanding of new and different methods adopted by the attackers.